Let's talk about completing the square method. So we are going to start with completing the square of a quadratic expression, all right? And then after that, we move on to finding the roots or zeros or solution to a quadratic equation by using the completing the square method. So first of all, we're going to talk about the completing the square method, but then for a quadratic expression, then we translate it into quadratic equations as well. So our general form of a quadratic expression, we have ax squared plus bx plus c, where a, b, and c are constants, can be written in this form: a x. Let me use different letters p so that it wouldn't appear that a here is the same as the a here. So p plus q squared plus r. So the right hand side, this side is what we call the completed square form of the left hand side. So this is a completed square form. The completed square form of the left hand side. So we have a quadratic expression and we're going to write it in this form, the form at the right hand side. And that we say that we've completed the square of the expression at the left hand side. So P, Q, and R are also constant, just as A, B, and C are constant. So sometimes instead of the P, it's going to be rather X plus Q squared plus R squared. In this case, it means that P is 1. In other cases, you have something like P here, X over here, and then plus Q all squared plus R squared, right? It's still the same completed square form. But then depends on which structure you've been given to convert the quadratic expression to. Sometimes when we're given this side, sometimes this, or sometimes this. So they are all the same. Now let's try with an example. Let's start this way. It's a different color. Let's have an example like, let me start with one that has the leading coefficient to be 1. X squared plus 10x. This is a quadratic expression since it doesn't have any equal to sign. We are going to rewrite this in a different form or in a completed square form. So the first thing you need to do is to identify your b, right? Over here b is 10. So over here b is 10. So number one, identify your b. But before that, make sure the coefficient of x squared is 1. So make sure the coefficient of x squared is 1 whenever you are completing the square. And if it's not 1, we'll talk about that, how to deal with it so that it becomes 1. And after that, you identify your b. Right? So over here, our b is 2. Sorry, it's 10. So b in this case is 10 and a is 1. We just need to find what b is. Okay. And then what we are going to do is to find half of b. We're going to find half of 10. That's 10 divided by 2. And that is 5. Right? So we are going to write the expression again. We're going to do x plus whatever b is, right? The value of b divided by 2. And then we square it minus the value of b divided by 2. And then we square it. So this is what we do. First of all, identify your b, divide by 2. And then add it in the bracket here. And then subtract it over here. So add and subtract all the time, right? So we're going to do substitution. You may not need to write the formula b over 2 or something. Just find your b, half it, and then continue. So from this question, half of b, which is b over 2, is 5. So it means you're going to our expression x squared plus 10x is equal to x plus b over 2, that is 10 over 2, we had 5, so 5 here, and then squared, minus 5 squared. So this is a completed form, right? The completed squared form of the left hand side. Now let's continue. X plus 5 minus 25, and that's all. So the x squared plus 10x is the same as x plus 5 all squared and then minus 25. How do we know that is true? Let's try to expand the right hand side and see if you're going to get x squared plus 10x. Let's expand here. The one in bracket to give us x squared plus 10x plus 25 and then minus the 25 outside. Then you realize that this one will give us 0. Right? So in the end, our answer is x squared plus 10x, which is the same as the expression that was given. And so that's why we complete the square of a quadratic expression. Let's try one more example. Now for question number 1 here, number 2 here, and number 3. We want to write all this. So the question is express each of the following. Each of the following in the form x plus a all squared and then plus b. So it just means we should complete the square of these expressions. So for the first part, identify your b. Our b is 8, right? So 8 divided by 2 is 4. 8 divided by 2 is 4. So you write it x plus 4 squared. Then you subtract it 4 squared. Then let's simplify it. X plus 4 all squared minus 4 squared is 16. And that's the completed squared form of the first expression given. So if you take your time and expand this, you realize that you get the same thing as x squared plus 8x. Then number 2, what is our b? Our b is negative, so don't forget the negative. Our b is negative 6. So half of b is going to be negative 6 divided by 2, and that is negative 3. Right? So we complete the square. We have x plus negative 3. Don't forget the negative squared. And then minus negative 3 squared. So over here we get x minus 3 all squared minus negative 3 squared is 9. So that is a completed squared form of question 2. If you take your time and expand, you realize that you are going to get the same thing as x squared minus 6x. And the last part, what is b? Our b is negative 3. Over here, we find half of b. Negative 3 divided by 2 will give us negative 3 over 2, or negative 1.5. So we complete the square, it's going to be x, and you know it's going to be negative 3 over 2 all squared, and minus negative 3 over 2 all squared. So let's simplify. We have x minus 3 over 2 all squared, and then 3 over 2 all squared is going to be 9 over 4. And that is the completed squared form of the third question. If you take your time and then you expand it, you get the same result over there. Now, last set of questions, and then we'll move on. Now, the last set of questions for the two term, we'll move on to another set of questions. But then for these ones, this is a case where the leading coefficient is not 1. But then the question still says we should express this in the form a into brackets x plus b all squared and then plus c. This is still the completed form or completed squared form. So, and as I said from the beginning, we have to make sure that the coefficient of x squared is 1. Over here, it's not 1. So what we're going to do is that we're going to factor out the 2. If it were an equation, we would have divided through by 2. But then because this is not an equation but an expression, we rather factor out the 2 or write the 2 out instead of dividing through. So 2 out, and then we have x squared minus 6. So 2 out, x squared minus 6x. Now, the one in brackets looks like one that we can easily complete the square because the coefficient of x squared is 1. So we're going to apply the method or the same procedure on what is in the brackets. So our 2 is still out. Our b is negative 6. So half of negative 6. So negative 6 divided by 2 is negative 3. We're going to write it. So 2 out. So when we get into the bracket, we write x and then minus b. It has to be plus b, but b is already negative, so it becomes minus b over 2, which is 3 squared. And then minus negative 3 squared. We close our brackets. Then we have 2 out, x minus 3 all squared minus 3 squared is 9. Now you multiply the 2 by every term in the bracket so that the bigger bracket goes away. So we have here 2 out, x minus 3 all squared, and then 2 times 9 is 18. And that is the completed squared form of the. So you see that it looks like a into bracket x plus b all squared plus c, where our a is 2, our b is negative 3, and our c is negative 18 for the first part. Now let's look at the second part. Same thing, we factor out our 2 so that the coefficient of x squared will be 1. So factor out 2, and then here becomes 7 over 2x. This time around, our b is 7 over 2. So 7 over 2 divided by 2 is 7 over 4. We just multiply the denominator by 2, 7 over 4. And then we work out the one in the brackets by completing the square. So 2 is written outside, and then in the bracket you have x plus b over 2, which is 7 over 4 all squared, then minus 7 over 4 all squared. Close the brackets, and then finally we have 2 here, x plus 7 over 4 all squared minus 49 over 16, that is 7 over 4 all squared. And you can expand the bigger brackets. It's going to be 2 out x plus 7 over 4 squared minus 49 over 16 times 2 is going to be 49 over 8. So it means over here our a is 2, our b is 7 over 4, and our c is negative 49 over 8. When you get to the graphical method, I'll explain to you what b, a, and then c mean on the graph and then in the curve of the quadratic equation. Now finally, the number 3 for this set of examples. We are expected to complete the square of this, but then our answer must be in this form. a minus x plus b all squared. Instead of having x plus b all squared minus a is rather here and then minus x plus b all squared. There's nothing different here, even though we are writing the 8x first before the negative x squared. You can rewrite this again, but then start with negative x squared plus 8x. Remember, I said the coefficient of x squared must be 1. Over here, it is negative 1. So what do? We factor out negative or negative 1. So that here becomes x squared minus 8x. And now the work becomes very easy because we can now see it is like a normal form that we can easily factor complete a square. So we have negative here. What is our b? Our b is negative 8, and half of negative 8 is negative 4. So we have x negative 4 all squared minus negative 4 squared. We have negative here, x minus 4. You don't need to expand this one, just leave it this way, minus 16. Now let's multiply the negative through. So we have negative x minus 4 squared plus 16, because negative times negative is positive. Now if you want to write it like this form, a minus x plus b all squared, it's simple. We just start with the 16. So 16 minus x minus 4 all squared. So it means that our a is negative 4 and then our b is positive. So our a is positive 16 and our b is negative 4. Now let's work on the full quadratic expression. So you have to express each of the following in the form x plus a all squared plus b, where a and b are constants. So now that we know how to, so this means we have to complete the square root quadratic expressions. And now that we know how to complete the square, you realize that from the previous examples, we just needed to complete the square of the first two terms, just this. And the same thing you're going to do, just pick the first two terms, the x squared term and then the x term, and you complete the square of the two, and then whatever becomes the result, we add the h to it. When we get to b, to do the same thing, we complete the square of x squared and then negative 3x. Then the final answer, we add 4 to it. So the same method, we use it. So let's start. Our b is 4, right? So we have 4. Half of 4 is 2. 4 divided by 4. 4 divided by 2 is 2. So we have x plus 2 all squared and then minus 2 squared. That's the completed square form of the first two terms, right? Then finally we add the h to it. So we have x plus 2 squared, and then this is negative 4 plus 8. X plus 2 squared, then negative 4 plus 8 is positive 4. So that is the completed squared form of this of question 1. It means that our, by comparison, our a is 2 and then our b is 4. On to question 2. Same thing, our b is negative 3. So negative 3 divided by 2 is negative 3 over 2, right? So we complete the square of the first two terms. So that gives us x minus 3 over 2 all squared, and negative minus 3 over 2 all squared. Then we add our 4 to it. Let's simplify it. X minus 3 over 2 all squared. Then negative 9 over 4 plus 4, or 4 minus 9 over 4. So finally we have x minus 3 over 2 all squared. Now we do this, negative 9 over 4 plus 4, or 4 minus 9 over 4 is 16 minus 9 is 7. So we have plus 7 over 4. And that is the completed squared form of question 2. If you take your time and you expand this expression, you realize that you get the same thing as the question given. Just for question 3 and question 4, same thing, we have to express each one of them in the same form. So this time around, you have to express them in the form a x plus b all squared and then plus c. But the difference is that in the first case, the coefficients of x squared were all 1 in both cases. So there was no variable outside here. This time around, the coefficients of x squared are not 1 in both cases. It means that something must be done, right? So that's why we have an a outside the bracket. Sometimes the a may be sent inside, and that's fine. We talk about that as well. So as usual, we just need to work on the first two, and then we add the last one. Here too, we work on the first two, we add the last one. Okay. So for the first two, remember the coefficient of x squared is supposed to be 1. So we pick the first two, and then we factor 3 out. So that we have x squared minus 4. Then our minus 1 is here. Sorry, 4x here. Now let's complete the square of the one in brackets. So 3 out here. B is negative 4. And half of negative 4 is negative 2. We have x negative 2 all squared. And then minus negative 2 squared. We close the brackets and then minus 1. Let's simplify the one in the bigger bracket. 3 out x minus 2 all squared, which doesn't need to be expanded. Then minus negative 2 squared is 4. Then our minus 1. Then we expand the bigger bracket. Okay. So 3 out x minus 2. Make sure you are not sending the 3 inside and writing 3x minus 6. Right? We'll talk about how to do that as well. Then minus 3 times 4 is 12 and minus 1. So finally we have 3 out here, x minus 2 all squared minus 13. So that is a completed squared form, or in this form. So our a is 3, our b is negative 2, and then our c is negative 13. Now let's talk about question 4. Here again, the coefficient of x squared is not 1, it is 2. So we factor out the 2, work on the first 2, and then we subtract or we add the last part. So let's do that. Let's factor the 2 out. And then we have x squared plus 5 over 2x minus 1. Okay. So for the first part, and then in the brackets, our b is 5 over 2. And half of 5 over 2 is 5 over 4. Remember I said you just have to multiply the denominator by 2. So half of 5 over 2 is 5 over 4. So it's going to be 2 out, and then a bigger bracket, x plus 5 over 4 all squared, and then minus 5 over 4 all squared again, close the brackets, and minus our 1 which is already there. Then we go 2 out. Let's simplify the one in the bigger bracket, x plus 5 over 4 all squared minus 5 over 4 all squared is 25 over 16 minus 1. Then we multiply the 2 outside by the 1 in the bracket. So we have 2 out, x plus 5 over 4 all squared minus 25 over 16 times 2 is going to be 25 over 8 minus 1. And then we simplify the numbers here. We're going to have 2 out, x plus 5 over 4 all squared. And then Negative 25 over 8 minus 1 is 25 plus 8, which is 33. It's going to be negative 33 over 8, and that is the computer squared formula. A is 2, B is 5 over 4, and our C is 33 over 8. Now let me come to this. The question says that we are to express the expressions given in the form ax plus b squared plus c. And so this is how we do it. Sometimes it's rather says do it this way: ax plus b all squared plus c, which means that we don't expect to see a number outside, right? That number outside should be sent inside the brackets. So instead of having a 3 outside here, it has to go inside the brackets here. Same applies with this, but instead of having a 2 outside, it has to go inside the brackets. But then it's still the same thing. You go by the same approach and then you solve it. But then this is what you do. When you get to the last part, 3x minus 2 all squared minus 13, and you want to send the 3 inside the brackets, we are going to take the square roots. Yes, we're going to take the square root of the number you are sending inside, right? So I'm sending the 3 inside the bracket. It's going to be square root of 3 and x minus square root of 3 times 2. So 2 square roots of this all squared minus 13. So whenever you are sending a number inside a bracket that is squared, you take the square root of the number. If you are taking a number out, you square it. So over here, the same thing. I want to write it in this form. It has to be square root of 2 and then x plus 5 square root of 2 over 4 all squared minus 33 over 8, and that's all. Right, so here we have square. Sometimes the numbers are such that if you take the square root, you wouldn't have any square root number. Let's say you have a 4 or 9 or 16 or something else. Take the square root and the number becomes a whole number instead of a set. Now let's try this. So I think this one comes in a quite different form where the constant rather stands out over here before the x terms come. But anyway, there's nothing wrong over here. So we still start the same way. We're going to rewrite it by starting with the negative 3x squared. Make sure you're taking notice of the signs, right? So negative 3x squared. It wouldn't change to positive because we are not crossing any equality sign. I mean, crossing as in how we say it, okay? And then plus 5x plus 2. Now we complete the square of the first two, right? Negative 3x squared and then 5x. Later we add our 2. Here again, the coefficient of x squared is not 1. So you factor out the negative 3 so that it becomes 1. X squared minus 5 over 3x. Right, so negative times negative will give us the positive over here. Then we add our plus 2. Next is find half of b. Over here, our b is negative 5 over 3. And half of that is negative 5 over 6. Remember I said you just have to multiply the denominator by 2. So it's going to be negative 5 over 6. So let's rewrite that. We have negative 3 out, the bigger bracket, x minus 5 over 6 all squared, and minus negative 5 over 6 all squared again, plus our 2. Let's continue from this side. Negative 3 out, x minus 5 over 6 all squared in the brackets, and then negative 5 over 6 all squared is going to be 25 over 36. close the brackets, plus our 2. Now let's multiply the negative 3 through. So we have negative 3 here, x minus 5 over 6 all squared. Then negative times negative will give us positive. 3 times 25 over 36 is going to be 25 over 12, then plus our 2. So we just have to find the value of 25 over 12 plus 2. So we have negative 3 out, x minus 5 over 6 all squared. Then 25 over 12 plus 2, that is 25 plus 24, which is 49 over 12. And now, so if you want to write it in this form, a minus b x plus c, it means you just need to start with the constant first. It's going to be 49 over 12, then minus 3 x minus 5 over 6 all squared. So over here, our a is 49 over 12, our b is negative is 3, and then our c is negative 5 over 6, and that's it. That is just one of the ways to do it. There is a second approach called algebraic approach, and we're going to look at that. So for the algebraic approach to the same question, I mean, it works for all the other questions that we solved. So after explaining the algebraic approach and if understood, you can go back to the other questions and then try the algebraic approach and make sure you get your answers right. So here also we are just trying to complete the square of this quadratic expression. And so what we normally do is that we complete the square of the left hand side and then manipulate it until it becomes something like the right hand side. But then for the algebraic approach, what we're going to do is that we rather are going to manipulate or expand the right hand side, right, to get the left hand side. So we're going to work the other way around, trying to expand what is at the right hand side until we get what is at the left hand side. So let's start. Let's expand the expression at the right hand side. So a here minus b. Expanding the one in bracket, we have x squared plus 2cx plus c squared. If that is not obvious to you, just take your time and do x plus c times x plus c, and you get this expression. Now we have a minus, so let's multiply the b through to get rid of the brackets. A minus bx squared minus 2bcx minus bc squared. So you take notice of the negative sign because this is minus, it affects all the other things inside. Let's rearrange them so that the x squared terms are grouped at one side, the x terms are at one side, and then the constant terms are at one side. So for the constant terms, for the terms that are not having any x attached to them, we have a here and then negative bc squared as one term. Then for the terms that have x attached to them, we only have negative 2bcx, so negative 2bcx. And finally, the terms that have only x squared is just 1, negative bx. We do that over here, negative bx squared. Remember, we are not crossing any equal signs, so no sign changes. Now let's rewrite the question here. 2 plus 5x minus 3x squared. What we're going to do over here is that we're going to compare the coefficients. We're going to compare the coefficients or the terms. We pick the x squared terms and then the x terms and constant terms and compare them. So for the left hand side, the coefficient of the x squared is negative 3. So negative 3, let me write comparing coefficients or comparing terms. or you can write comparing terms. See that coefficient of x squared at the left hand side is negative 3, and coefficient of x squared at the right hand side is negative b. So negative 3 is equal to negative b. That means that b is equal to 3. So the value of b has been found. Now next is to find the value of c or a, any one of them that we can easily find. Let's go to the terms with x, or the coefficient of x. At the left hand side, the coefficient of x is 5. Positive 5 is equal to coefficient of x at the right hand side is negative 2bc. So we equate that here, negative 2bc. But we've already found the value of b, alright? We just need to do substitution over here. 5 is equal to negative 2 times b, which is 3, times c. And we have 5 is equal to negative 6c. Divide both sides by negative 6, here by negative 6, and then our c is equal to negative 5 over 6, the value of c. So we found b, we found c, and we just have only a to find. Let's compare the last set of terms. Lastly, the constant term at the left hand side is 2, and the constant term at the right hand side is a minus bc squared. We're going to equate them. 2 is equal to a minus bc squared. We've already found the values of b and c, so we just need to do substitution. 2 is equal to a minus b is 3 and c is negative 5 over 6. So bc squared, so c has to be squared. And we have 2 is equal to a minus 3 times 25 over 36. Let's simplify it. 2 is equal to a minus 3 times 25 over 36 is going to be 25 over 12. So we send this to the other side, and then we find our a. A is equal to 2 plus 25 over 12, and that is 49 over 12. So yeah, we found the values of a, b, and c. Now we can easily write our final answer. That 2 plus 5x minus 3x squared is equal to, or is equivalent to 49 over 12 for c, minus b is 3, and x minus 5 over 6 all squared. Exactly what we found, or we got from the other method over here. So same thing. So this is just the algebraic approach, and as I said, you can go back to the previous videos, and instead of completing the square, try the algebraic approach as well, and make sure that you have more than just a method of doing the same thing, so that at any point in time you can just apply any one of them. Now, after completing the squares of algebraic expressions, now let's move on to solving quadratic equations by completing the square method. This time around, it's not going to be an expression but then an equation with an equal sign. It means that we are not just going to complete the square, but we're going to find solutions as well. This time around too, we go by the same approach, but then when we get to the final part, we equate everything to 0. Right? So let's start off by the first example here. 2 plus 5x minus 3x squared equals 0. We have to solve this for x by completing the square. But this is what we already did over here. 2 plus 5x minus 3x squared. When you completed the square, our final answer was 49 over 12. minus 3 here, x minus 5 over 6 all squared. So this and this are the same. We just equate it to 0. Now next is to just move one of them to the other side of the equal sign. I'm going to move this part to the other side. But I'm going to write that one first. So I have 3 out, x minus 5 over 6 all squared is equal to 49 over 12. And the next thing is to divide both sides by 3. Here by 3, here by 3. And dividing a fraction by a number means multiply the denominator by that number. Okay, so we have this part is x minus 5 over 6 all squared is equal to 49 over 36. Next, we square root both sides. We'll find the square root of both sides because we need to find the values of x. And before we go on with that, you know the square root of 4 means that what number do we multiply by itself to get 4? And we have two answers. The answers are positive 2 and negative 2. So we are going to write it as plus or minus 2. This is going to be a notation. Root of 9 is equal to plus or minus 3. Root of 5 is equal to plus or minus root of 5 because we can't have a whole number answer. So this is a set. The same thing we are going to do to our question. So back here, we take square root of both sides, square root of the side. So left we have x minus 5 over 6 because the square and the square roots cancel out. Now after the equal sign, we have square root of 49 is 7 and square root of 36 is 6. It's going to be plus or minus as we understood already. Now next we transpose or we move the 5 over 6 to the other side with the equal sign and find our x. We do that here. X equal to 5 over 6 plus or minus 7 over 6. So there are two numbers here or two solutions here. The first one is 5 over 6 plus 7 over 6. We take the positive part and then next we take the minus part. So x is equal to 5 over 6 minus 7 over 6. Now x equals 5 over 7, 5 plus 7 is 12 over 6 is 2. Or 5 minus 7 is negative 2 over 6, negative 1 over 3. So our solutions are x equal to 2 or x equal to negative 1 over 3 for this particular question. Now the next question is this: 3x squared minus 12x plus 1. We are to complete the square. It's not plus 1, it's minus 1. Minus 1 instead of plus 1. We are to complete the square of this. And we've already done, we have to solve it by completing the square. We already completed the square of the expression. And the answer we had was 3x minus 2 all squared minus 13 equal to 0. We add that to it. And we go by the same approach, send the 13 to the other side. So 3 here, x minus 2 all squared is equal to 13. You don't take the square root until you've divided. Right? You can still take the square root here, but then you have to make sure you square root the 3 as well. We're going to divide first, and then we have x minus 2 all squared is equal to 13 over 3. Next, we take the square root of both sides. And we have x minus 2 is equal to, let me add plus or minus, so plus or minus root of 13 over root of 3, which is the same as root of 39 over 3 after rationalization. So we have x is equal to plus or minus 2 plus or minus root of 39 over 3. So yeah, the answers are 2 plus root of 39 over 3, or x equal to 2 minus root of 39 over 3. And these are answers for the second question. Now let's do the last question, which you've not done. Solve by completing the square. X squared plus 4x minus 7. You can pause the video and then solve this, hoping that you get it right. So let's complete the square of this stress. Our b is 4, so half of 4 is 2. It's going to be x squared plus 2 all squared minus 2 squared minus 7 equal to 0. X, sorry, there shouldn't be any x squared here. There's an x. So we have x plus 2 all squared minus 11 is equal to 0. 11 goes to the other side before we take the square root. We can't positive. Now square root of both sides, we're going to have x plus 2 is equal to plus or minus root of 11. X is equal to negative 2 plus or minus root 11. And you know how to split them, so that's the answer. Or you can write negative 2 plus root 11 or negative 2 minus root 11 as your answers. And that is completing the script. So you realize that there are times that the factorization method actually fails, but then the completing the square method never fails. Right? This method and the next method we're going to talk about will never fail you. So it's okay, it's better you